today's topic is about latent aspect rating analysis of review text data. This is joint work with my student Hongning Wang and also my former student Yue Lu, who is now in Twitter. So as part of the data that's growing on the web, review data has actually been growing quite a bit, and I think most of us are familiar with reviews in Amazon. When you try to choose a product, you probably would like to read the reviews to see what other people have said about the product. And so these kinds of review data have been very useful for us to help us make decisions in many ways. So this slide basically is just to show that there are all kinds of reviews on all kinds of things, including products, services, and also you often have a lot of reviews. And here the number actually is not that big. There are other cases where you have many more reviews. And the reviews tend to be very useful. That's why we care about that. People express opinions with ratings and also text. So all these make this a valuable resource for people to leverage in optimizing decisions. However, the main question that's interesting to us is how can we develop a tool to help people automatically automatically understand the opinions and then provide services to help people digest and explore the opinions efficiently. Otherwise, people are overwhelmed with a lot of opinions. It takes a lot of time to sift through a lot of review data to really get the or the most relevant opinions. So because of the importance, people have worked on this problem in many ways. So existing work has looked at how to do opinion mining, where we can categorize reviews according to opinion polarities. For example, you might see some visualization like that on the top, where you can see the opinions on different aspects and compare the sentiments. Right? Or people have also worked on all kinds of ways to summarize reviews, mostly extraction of informative sentences, sometimes group the sentences into different aspects. And people have also worked on opinion retrieval, where you can type in any queries to find the opinionated sentences, or you want to match maybe objects in the reviews with the right objects to facilitate ranking of objects based on reviews. This is not a complete list of all the relevant work, but mostly existing work has either relied on some special heuristics in some domain, like a product domain, to achieve some of these goals, or some supervised learning methods that rely on detailed annotated data to get the work done. And so our motivation is to try to develop techniques that don't require that much manual work and don't require a lot of domain-specific heuristics, so that the method can be used for a variety of entities of all kinds of reviews. So more specifically, the motivation for this line of work is the following. So this is a typical review of actually 2 reviews of hotels, right, from TripAdvisor. You can see people give overall rating like 5 stars here, and then they write about their opinions about the hotels. The problem is that the overall rating, although useful, is not so informative, because people might like a hotel because of its good location, or people might have liked the hotel because of good price. So how can we understand the details of the opinions? That is, how can we infer ratings on different dimensions, such as location or service or room condition, based on the overall rating and the text descriptions? If we can do that, then we would be able to first review more detailed opinions, and secondly, it would allow us to rank hotels based on more precise criteria, such as based on price or based on location. And this is going to be more helpful to people to sift through all the reviews. Furthermore, we also would like to infer the aspect weights. So what are those weights? Well, those are the relative emphasis of the reviewer on different aspects when the reviewer tries to compose the overall rating about the hotel. Why is that interesting? Well, even if we can decompose the overall rating into aspect ratings like what you have seen here, right, we may still not get a good picture of the exact price of a hotel. Let me give you one example. Suppose two hotels both have 5 stars on the price dimension, but they are written by different people. So one is written by a casual traveler that's on vacation, and that the person maybe a student. And so this person would probably care a lot about the price as opposed to service. So when this person gives a 5-star, we can guess probably the price is indeed cheaper, let's say around $100. But another person might be a businessman, a CEO that's traveling for business purpose. So because the person cares more about the service, so a 5-star might actually mean $200 or even higher. So just looking at the rating on a particular dimension is still not informative enough. So we hope to be able to infer the weights. So the weights together with the ratings would give us a better idea about what are the real opinions, or what are some pros and cons of a hotel. Now with these weights, we could potentially do personalized recommendation of hotels. Suppose I'm now in the mode of caring about the value, and I don't care that much about the location. I could then use my profile to retrieve the reviews written by those reviewers that are believed to have a similar profile. And if we use those reviews to recommend hotels to me, presumably it would be more relevant to my interest. Okay, so that's and then these weights can also be used to analyze just users' rating behavior. So these are the main motivations. So the main question is how can we do this? So in order to do this, we sort of formulated the problem in a general way, which we call the latent aspect rating analysis. So the problem is defined as follows. Given a set of review articles about the topic with overall ratings, for example, hotels or restaurants with overall ratings, and we hope to use a program to automatically generate the following. First, we want to discover the major aspects commented on in these reviews. In the case of a hotel, we want to discover the location or price or service aspects like that tend to be commented on in the reviews. Secondly, we want to decompose the overall ratings into ratings on different aspects. So we want ratings on each aspect. Thirdly, we want to also generate the relative weights placed on different aspects by reviews. Right, so, and as I just also explained, that if we can do this, there will be many applications. For example, we can easily support the opinion-based entity ranking, not only based on overall rating, but also based on aspect ratings. We can easily generate the aspect level of opinion summary. Right? So show the user what are the major aspects that people talk about, and what are their opinions on different aspects, potentially also pull out sentences on each aspect. We can do reviewer preference analysis. We can look at the when reviewers like a hotel, where do they place a high weight? Which dimensions tend to cause reviewers to like the hotel? We can do personalized recommendation of products. So the rest of the talk is basically based on 2 papers that we recently published in the data mining conference, KDD. So the first is to tackle the problem in an easier situation, where we assume that the user would specify all the aspects by a few keywords, so a few keywords for each aspect. The second part will be about a more difficult scenario where the user is not going to give us any specification of aspects. So we are going to solve the problem to discover both the aspects and also decompose the ratings and also infer the weights. So basically the difference here is that the first part will solve the problem partially. I mentioned 3 kinds of output, and we're not going to generate the aspect output. We're going to assume that the user will actually tell us what they are interested in. So that itself is also interesting because, excuse me, that gives the user some freedom to sort of steer the process of analysis. However, there are also situations where it's harder to pre-specify what are the interesting aspects. Right? So then it might be interesting to automatically do all these. So that would be the second part. So that's the first part that was published in KDD 2010. So in this scenario, when we are given a few keywords to describe each aspect, we could solve this problem in 2 stages. The first stage is to do aspect segmentation. So this is an illustration of the basic idea. In the first stage, we'll do aspect segmentation. That just means based on the keywords given by the user, we're going to separate the sentences into different groups. Some sentences match some keywords better than others, so these sentences will be put in that category or that aspect. In this way, we can then separate all these sentences into different groups corresponding to the interesting aspects from a user's perspective. And in the second stage, we would use a model based on rating regression. It's a regression model. Basically, we are going to assume that the overall rating is dependent on the observed text data in the following way. First, we have this actually is designed to have automatic advance by my student. Sorry. So here apparently I could explain this more quickly than I could. So first we assume that there is an aspect rating on each dimension, like the location of the hotel, and that depends on the terms that describe that aspect, together with sentiment weights on the terms. So for example, here we see these words are mentioned these many times in the sentences discussing this dimension, this aspect. And these are the sentiment weights on these words. So some words convey positive sentiment, some other words convey negative sentiment. So we assume that the aspect rating here is just a linear combination of these frequencies weighted by the term weights. And in this furthermore, the overall rating is assumed to be generated by doing a weighted combination of all these aspect ratings. Here we have the weights shown on the last column here. These weights indicate the emphasis in a reviewer's mind, or we assume that that indicates a reviewer's emphasis on different aspects when the reviewer composes the overall rating. So in this case, for example, the more weight has been put on this aspect. So therefore, the overall rating is more influenced by that. So this is a 2-stage approach where we first segment the sentences into different aspects, and then we set up a regression that involves latent ratings on different aspects. So we basically observe the text data and the overall rating. And we want to infer the latent information that corresponds to 3 kinds of things. First, the sentiment weights on terms. Second, the aspect ratings. And third, the aspect weights. And you have a question?
So I've had time to be doing arithmetic in my head. And I thought maybe the scores SI are the combinations of the W's and the betas.
Yes.
But maybe they don't, maybe this is only a picture and not.
This is the illustration. They don't necessarily give the exact value. You actually caught some errors here. It might be because I changed some terms here. Or maybe it wasn't accurate in the first place. So this is meant to be an illustration.
Okay, it's a conceptual picture.
Yes, yes. So I say a little bit more about the model, but this is basically the idea of the model. So again, we observe the text data and the overall rating. We hope to basically guess these values so that this whole thing would work well. That means the overall rating is predicted based on weighted combination of aspect ratings, which in turn depend on the sentiment weights of terms in combination of term frequencies. So a little bit more about how we do this. Aspect segmentation is based on a very simple existing approach. So basically, we first use each sentence as a unit, and then we just score a sentence based on how many seed terms you match. Very simple technique. And then we group the sentences tentatively into these aspects. And then we do a bootstrapping step where we look at the additional keywords that are in the particular aspect that can characterize the aspect very well. Those are the terms that have high chi-square scores with respect to the aspect. And we add those additional terms to the seed list and then do another round iteration, like a pseudo feedback. So this is, and the reason why we did not look into this part in detail is because there are standard techniques that can do this well. And it seems that this is working sufficiently well for our purpose, although this is a step that we haven't really looked into deeply. It's an orthogonal problem. Instead, we looked at more at the second stage, which involves a new model for modeling ratings. So that's a focus of our work. So the second part basically tries to just connect the word frequencies with the overall rating by using aspect ratings and weights. So basically, aspect ratings are treated as bridges to sort of bridge the gap between the term frequencies, the observed text description, and the overall rating. And the model itself is a generative model for overall ratings conditional on the observed text. It involves some, using a non-standard term, two-stage regression. So I explain this in a moment. So this is just showing the model using graphic model notations. And for those of you who are not familiar with this, basically shows the dependency of random variables, and the shaded nodes are the observed variables. And so here there are some key observations here. So this variable S stands for aspect ratings, and that you can see that depends on the observed words W, and that also influences R, which is the overall rating. So the overall rating depends on the aspect ratings. And then the aspect ratings depend on the words and the sentiments of words. So beta indicates sentiment of words. And then the overall rating is based on the sentiment, the aspect ratings, and also the weights on different aspects. Here, the weights are indicated by alpha. So a little bit more detail about this. So let me put both pictures together here. So now I introduce some symbols to denote the data. W is the word vector, the observed text data in different aspects. And beta is the sentiment weights of terms. And then S is the aspect ratings. Alpha is the weights on different aspects. So first you can see the aspect rating is dependent on the words. It's basically weighted by beta, as we just talked about. And then the aspect ratings are combined based on weights alpha to predict the overall rating. Here we assume the overall rating is a random variable. It actually follows the Gaussian distribution with the mean that's equal to the weighted combination of aspect ratings, and with some variance parameter. Yeah, again, sorry, I did not notice that there's automatic automatic advance of slides. So yeah, so this is how we connect all these variables together to set up a regression model. And so again, using the observe the text data to predict the overall rating through this kind of structure. So the conditional likelihood of the rating given a particular review document would be written like this. This basically first have an integral over all the possible alphas. I should also say that we assume that the weights on different aspects indicated by alpha here are not independent. So when people like some aspect, people might tend to like some other aspects. So we now put the multivariate Gaussian distribution here. So the alpha is drawn from a multivariate Gaussian. So the covariance might capture some dependency here. So that's why you have the integral here. So because we don't know what's the weight. And then once we have that, and the rest is fairly standard based on this model setup. Basically, it says that the aspect rating is first given by the weighted combination of term frequency, and then the overall rating is based on the weighted combination of aspect ratings.
Can I?
Yes.
How did you figure out the square?
Oh, good question. So how do we figure out the sum of these values, right? So that's what I'm going to talk about in the next slide. How do you estimate the parameters, right? So, and I'll talk about this in two steps. First, let's assume that those parameter values are known to us. How do we compute the variables that we are interested in, the aspect, the ratings, and the weights, right? So suppose the parameters are already determined. So the sentiment weights, sorry, I should have seriously practiced before I do this. I only silently practiced with myself. This is, so then the aspect rating can be easily computed by this method. We observe the term frequencies and beta values are already known. So it's easy to calculate the aspect rating. And then the aspect weight is a little bit harder because it's assumed to follow a multivariate Gaussian distribution. So we need to use maximum posteriori estimation, a map estimation. Basically, we just choose alpha that's the maximum according to this posterior probability. So this, of course, this then does not have an analytical closed form formula for solution, but we could use some numerical algorithm to solve the optimization problem. So essentially, we're going to choose aspect weights that are sort of consistent with our prior, the estimated parameters of the multivariate Gaussian distribution, and also consistent with the observed overall rating and the aspect ratings. So now the second part of the problem, which I think addresses your question, how do we estimate those parameters? How do we know the values of those parameters? Here we use maximum likelihood estimation. That just means we're going to adjust all those values that are hidden from us so that we will maximize the probability of predicting the overall score. So mathematically, you can see that likelihood function is like the function consists of several variables that represent our parameters. And we just basically solve this optimization problem by finding the appropriate values for those variables so that the conditional likelihood reaches the maximum. So conceptually, that's how we find the parameters. Now intuitively, that just means we look at a lot of reviews. We try to adjust these values so that we can best predict the overall ratings. And that would mean, for example, the sentiment weights for terms should be somewhat consistent, because if you don't assign the right sentiment weights to some adjectives or some words that convey strong opinions, then your predicted aspect ratings will not be accurate. Therefore, the predicted overall rating is unlikely as accurate as if you assign the right sentiment. So this is what intuitively would happen.
So it's assumed that a word has the same sentiment for all writers.
Yes, yes. So the beta vector, which indicates the weights for different terms to indicate the sentiment, is actually global. So it's a shared parameter. But it varies according to different aspects. So when we talk about the room condition, then there is a set of sentiment weights. When we talk about the price, there will be another set of weights. But for all the reviews, we have assumed that the terms have the same weights.
So rather nice, quite nice, and nice. Nice might have rather different
Yeah.
weights.
So this actually, yeah. So we currently couldn't capture such subtle difference just because it used the bag of words representation. It's actually a limitation that I will mention in the end. It has to do with how do we present the data in a more meaningful way. Right now, it will miss that. We'll treat it just nice as one nice.
Right.
Do you allow negative weights?
There are negative weights. Yeah, there are negative weights. I show you some sample results. So the actual algorithm is an EM style algorithm. Basically, it's an iterative numerical algorithm to optimize the likelihood function. And just some brief discussion about the relationship between this model and some related models. So it's related to supervised learning in that we will use some overall ratings, right, as supervision. It's not completely unsupervised based on text data. But it's also kind of different in that we don't use the aspect ratings. We don't assume that we observe aspect ratings. So that part is unsupervised. It's also related to unsupervised learning, but then we still have some supervision. So we have some overall rating as an indirect signal for supervision. And it's related to topic models, for those of you who are familiar with that. But the topic models, though, are trying to model text. So it's usually an arrow pointing to the words indicating that there's a model for generating text. But it's something that I will actually talk more about in the second part as we try to also discover the aspects. So it's an interesting new model that would allow us to actually analyze reviews in an interesting way. So now I'm going to show you some experiment results of this model. The data set is from TripAdvisor. Why do we use that? That's because these reviews happen to also have user-generated aspect ratings. So those ratings can be used as a gold standard to validate our prediction. Of course, we don't use the aspect ratings, but we try to see if our predicted aspect ratings are close to what users have given. There are 7 aspects that I listed here, typical meaningful aspects for hotels. The ratings are 1 through 5 stars. Sorry, it's a typo here. And there are over close to 2,000 hotels, 100,000 reviews. And there are about 8 sentences per review. So first, some results about just some sample results. Okay, so this table shows how the decomposed ratings, aspect ratings, based on the same overall rating. I think in this case, probably it's all 5 stars. Yeah. So if you just look at the overall ratings, then it's not very informative. They all have the same overall ratings. But when we decompose the ratings, we can see there are some differences. For example, this hotel seems better in value, and the other 2 hotels seem to be better in other dimensions. So this gives user more detailed view of the opinions. This is another way to look at the decomposition. So here we look at the 2 different reviewers and look at their reviews on the same hotel. And so in this case, we can also see different people really have different views. So for example, this person really liked the value but didn't like the room condition and didn't like the cleanliness. But the other user seems to have opposite opinion in terms of the room condition. Yes?
There are two values there. So one is the one found by your algorithm and one is the rating given by the user?
You're correct. Yeah, thanks for filling this detail. I should have explained this. Yes. Yeah. The one in the parenthesis is the gold standard rating. So if you look at the review, this is the real review of the second review. Sorry, I hate this now. So this is the second review. So you can see that the review has said the room was a little smelly, and then you're making a little bounce. And then for the price we paid, we didn't have excellent time besides those small things. So you can see the value dimension was actually was rated high. So it's that's another sample result. And here are some sample sentiment weights. I learned for different dimensions, different aspects. Here there are only 4 aspects shown in 4 columns. And then the top part shows the highest positive values. And the bottom part shows the negative weights. So these can be regarded as some byproduct that can be used as aspect-specific sentiment lexicon. And if you look at the words there, they seem to make sense. But it's interesting that it can pick up some words that are not themselves adjectives, right? But when they mention those, they tend to mean positive opinions, it seems that. So this is, so I've shown you that this decomposed aspect ratings, the second column, and this is the first column, the beta vector, the sentiment weights. Now what about the third column, the relative weights? Right? So actually, before I talk about that, there's some results about the quantitative evaluation of the accuracy. And I'll show you the last column in a moment. So this is a quantitative comparison with some other prediction methods, and also it tells us how accurate that we can predict those ratings. And that's where we have some interesting evaluation issues. Again, something we can talk more later. So here we use the 3 kinds of measures. One is mean square error. That's just to compare the predicted rating with the expected rating to see how far away you are from that. The second kind of measures are correlation measures for aspect ranking and review ranking respectively. So for aspect ranking, we basically look at the order of the aspects, the 7 aspects. Sorry. So the 7 aspects based on the gold standard. Let's say this reviewer has liked the price the best among all the 7 aspects. So price would be the first. And then if we sort the aspects based on the aspect ratings given by the user, we have an order. We can also do the same based on the predicted ratings. And the idea is to see if we use the predicted ratings to rank the aspects to see which aspects the reviewer likes the best. Can we recover the same order? So that to see whether the 2 orders are the same. And that's aspect-based correlation. Review-based correlation is to rank hotels based on the predicted aspect ratings. Let's say rank them based on the predicted price rating. Again, we can do the same to do this ranking based on the gold standard, and also do the same based on the system predicted ratings. The idea is to see again if we rank hotels based on price, would we get the same order as what we would get based on users' true aspect ratings. So this is another value. And then the third measure is just the ranking performance, and this is to this is similar to ranking the hotels, but since correlation looks at the overall ranking, maybe a user only is interested in the top few hotels, right? So maybe it makes sense to use some traditional information retrieval measure to do that. So then we assume the top 10% of the hotels given by the gold standard ranking as relevant, sort of relevant hotels. And then we compute the map, mean average position of the system ranking to see if we can rank the same 10% of hotels on the top. So these are the results. And some baselines are include some from the previous work that are based on some heuristic analysis of also the word frequencies, but not based on this kind of detailed models. And also these are the local and the global predictions. And there are also some supervised learning methods that are based on either the overall rating or the gold standard aspect rating, which is really an upper bound because we are given the aspect ratings as training data. But overall, we see that this models perform the best by these two measures, the aspect ranking and the map ranking. But in some other dimensions, it didn't actually perform as well as other models. And actually what we found is that the aspect, this mean square error, seems to really favor a simple strategy. That's to assign the overall rating to every aspect. Right? That kind of decomposition is not useful to distinguish what aspects are liked by users. But when measured by mean squared errors, that kind of methods tend to do pretty well. And similarly, when we rank based on different, rank these hotels in different levels or rank different computer correlation using different rankings, aspect ranking and review ranking, we tend to get different results. I think for different application purposes, we might want to trust one more than the others. But it's still a question how we evaluate these results appropriately.
I don't quite understand why there is boldface in some places.
Oh, it's just that, sorry, this is just to emphasize that on these two dimensions, by these two measures, this method did the best.
Because it's higher than everything but SPR.
It's compared to the
sorry. Maybe there was a confusion because this one should be really excluded from
because this is
the upper bound.
Ideal upper bound.
Yeah.
Yes.
So this is square error, the smaller the better.
Right.
You can see there are some other approaches that can better approximate the errors. But then it's a question whether you penalize the cost of using a square error more than it's penalized more.
So, something you said about the mean square error tends to favor a flatter distribution that's similar to the overall rating. Is that what you're saying? If you rate the aspects according, give them the overall rating to each aspect, it tends to do better when evaluated.
Yeah, if I remember correctly, it is like that, and then it's because on average the users rating is about around the overall rating.
So it's because ranking makes small differences big, right?
Right.
I mean, difference of 0.01 turns into a difference between 1 and 2 in ranking.
Yeah.
You could also, if you wanted to tailor your method to do better on that metric, then you could put a different prior over the alpha.
Yes, good point. We could put a strong prior on alpha to say that they should all be the same or yeah, so then that would work. But then I have a feeling that I think it's similar to precision and recall, and then you have to report both. But here it looks like we also should report all these, but it's not all that clear. What are the basic measures that use?
What if you take a really unpleasant metric, which is the number of scores that aren't correct? So you only get
correct meaning equal.
Yeah. So you need some way to bin the predicted value, but then you either get it right or not, which the naive user would say, yes,
Yeah. So, but then. In that case, since this is based on regression, I guess we won't be able to have the exact integer, but maybe an epsilon like range. Yeah, that's also an interesting way of looking at it. Looking at how many cases we actually get very close. And that's a good idea because if you do average assignment, if you use the strawman baseline, probably you won't get many of those correct. Or maybe you can, because it's a discrete value. At 1, 2, 3, 4, 5,
If all the values are either 3 or 4, you'll get half the
yeah, that's fine. Yeah, but that's a very good idea, I think. Yes.
How come the local prediction for review is higher than the less line? Local prediction, correlation, the review.
You mean this one?
Yeah.
Yeah. So this is the result just means if you rank the hotels based on the predicted rating by the local prediction, and that's mostly also use the text basically to try to learn to predict the basically you can imagine it's roughly like using the global ratings as if they are local ratings, and then using the text in that aspect to try to do the prediction. Then this means that the ranking of the hotel is more correlated with the ranking of the hotels given by the gold standard. It's more correlated than if we rank them based on the predicted ratings of this model. That might also be because it's the overall ranking of hotels based on either aspect might be still strongly correlated with the ranking based on overall. But this is still something that I think that's worth further investigation. Whether this kind of measure is really meaningful. Second, and what's the problem of the model? There are some problems. And my feeling is that you can't be good at all these, because if you emphasize one kind of ranking, you might lose the other. That's why I think evaluation is also quite interesting. Yes.
So do you have any results for the speed of your algorithm?
Yes, in the paper we discussed this. It's actually a algorithm that's fairly efficient. I think it took just a few minutes to process a lot of review data. So this is the algorithm itself. It's an iterative algorithm. You do have to go through all the reviews, but it's I think it's linear to the size of the review, and then also the number of parameters would be also a factor. But the parameters, you can see there aren't also really many parameters there. Yeah, so, okay, so now we look at the third column, the weights, inferred weights. And we try to see if those inferred weights are really meaningful. So these are the, we partition the hotels into two different groups: cheap hotels that have prices around $100, and expensive hotels that are far more expensive. And we looked at the average weights we inferred for reviews that gave 5 stars to these hotels, and for reviews that have given 3 stars to these hotels. And then these are the weights, the average weights that indicate whether people cared more about service or price. So this shows that when people like the expensive hotels, a lot of weights have been put on service. And when they didn't like it that much, a lot of weight has been placed on cleanliness. And then when people like the cheap hotels, a lot of weight has been put on value. When they didn't like the hotel, and also the problem is the condition.
There's clearly a message here for people who own hotels.
Yeah, cleanliness. yes, that's, yeah. And also, we tried to do sort of more analysis by ranking the hotels based on the reviews that have different ratios of weights. So this is the value to location weight ratio. If the ratio is high, that means the review really has a high a lot of emphasis on the value versus the location. And if the ratio is low, that means if the ratio is low, that would mean that the user cares more about the location rather than price. And if we rank the reviews in that way, and we will see the hotels that are recommended based on the top ratio reviewers are indeed cheaper the price than the bottom part. That means when they give a 5-star to the price, and if they really care about the price, and then the price tends to be cheaper than if they care about other factors. And this is fairly consistent across a lot of hotels. These are some cities that have most hotels in the data set. So that also indirectly indicates that the weights probably are meaningful. So here are some sample results of summarization based on the decomposed ratings. And then you can easily see that this kind of summary is more informative than the original reviews. And we can see the opinions of different aspects.
So is this done by trying to pick the highest and lowest, examples of the highest and lowest for each?
Yeah, I believe so. That's yeah. So you can get a good picture, and then also the corresponding sentences that can be retrieved from reviews that give low ratings. And this is some result on personalized ranking of entities. So this is when I give a query like this, where I say I emphasize a lot on the price and I don't care that much about others. And we could use the reviews that are written by reviewers who have similar weights to recommend hotels, to rank hotels. Or we could do non-personalized ranking where we just predict the price dimension rating to rank all the hotels. And you can see this is the real price of these hotels. And then indeed a personalized ranking would give us hotels that are cheaper.
I don't know how far it is from Punta Cana to Los Angeles. It might not be reasonable to stay there.
I also don't know that much about the
Makes a lot more to get from.
But in reality, I think people would have other preferences also, right? So but we hope this also helps us assess whether the weights are really meaningful. So I actually ended up spending a lot of time in explaining the first line of work, which I think is also fine because the second part is really to solve the problem of aspect discovery together with other mechanisms. And the remaining part is actually kind of similar. So this is a replay of the two-stage approach. The main concern is that there might be a gap between these, in that the aspects specified may not be the major aspects commented on. So we hope to see if we can sort of do this in a unified way so that we can simultaneously discover aspects that are also commented on. And as I mentioned earlier, the two-stage solution is not necessarily bad because users can easily specify the aspects that are interesting. So, but the problem is that sometimes it's harder to specify the aspects. So in this unified generative model, basically we try to explain both the review text based on topics and also the overall ratings. So we assume there's an entity like a hotel here, and then the reviewer would have some aspects in mind to comment on. Right? So, and then each aspect has some word distribution that tell us what are the words that tend to be used to describe opinions on that aspect. So the user would write a review based on these regular topic models, similar to that, and then we would assume that the aspect ratings are dependent on the terms in that aspect in the same way as I described earlier, and then the rest is the same. So the main tricky part is how do you coordinate this with the aspect rating part? How can we connect them? Before we have explicit segmentation, but now we don't. This is all uncertain. So how can we coordinate that? That was a main technical challenge here. So basically the framework looks like this, a new framework. And if you still remember vaguely the picture earlier is that we did not have the topic model part here. So this if you look at this part on the other hand, this for people who are familiar with LDA, this looks very familiar to the LDA. Basically, you generate text by join words from multiple multinomial distributions. But this part is similar to the LARA model, the regression model that I just talked about. Right? So you have aspect rating and then you generate the overall rating. Again, similar. But the main point is that these are connected, these are coordinated. So that the topic chosen here has to be coordinated with the aspect here. And this is based on a set of coordinated sentiment values and word distributions. It's basically sort of a way to simultaneously characterize the sentiment of words in that aspect and also the word distributions. So this replay, let me, what's that?
Sorry. Will you leave us a copy of this slide?
Yes, yes, yes. I have to apologize for this automatic replay. That's a surprise to me. When I look at the just silently and then talk about this, it didn't go that fast.
You looked at it and you said, "I know what that means."
Yeah. So basically, so you can see now the words are generated using basically the same model as your aspect model or the LDA style model.
But so are you allowing that particular parts of the review will correspond to different topics, or are you finding the mixture of topics in the review as a whole?
We also find the mixture of let me try to make sure I understand the question.
Well, the pictures seem to show that in the middle part it's the red topic that's generating the words. But the usual LDA type model would not fix a topic to a sub-portion of a document. It would keep the mix open.
It's the same as the usual LDA model. I think this is misleading.
Okay.
Yeah, so the actual topics would be like broken with colors.
Well,
like
really,
that.
the whole thing.
In fact, that's the main problem. Yeah,
right.
That's the main problem with bag of words, actually.
Yeah.
So let me just.
So that's the way to make the slide. Words should have the same color, but they should be rearranged alphabetically.
Yeah. Yeah, that's a good point. So this part models rating, and the rating formula is similar. So it's similar to what we saw before. And when we put them together, then we basically, let me just, because of the time limit, let me, see if I have I don't have the likelihood function, so here. So that's probably a reminder for me to stop. Let me see if I can concisely explain what's happening here. So basically, the two parts are from the two separate models, as topic model and the rating regression, and then they are joined together through this coordination. And that coordination basically would ensure that the sentiment assignments of terms would be consistent with their co-occurrences on the topic side. So this way we can hopefully discover aspects that are really commented on. So that's a very simplified way of saying what's happening here. So, and in comparison with the supervised LDA, which is a new model developed by David Blay and co-authors.
You can't call it new if it's 9 years old.
Yeah, well, sorry. No, this is wrong. So
it's not
this is
old.
2008. The old LDA was 2002, 2003, or sometimes say people. But this is a supervised LDA that has actually some supervision from the ratings. Okay, sorry, this is supposed to be 2008. Then so this. Yeah, so compared with this supervised LDA, we predict the aspect ratings. So this is something that's not there. And compared with our old model, we basically discover the aspects. So I don't think I have time to actually talk about this, but the inference part is more complicated due to the complexity. But the idea is the same. So the likelihood, the parameter is estimated based on likelihood maximization. And then the other interesting variables are computed based on posterior distribution, based on the parameters. The only difference is that the optimization problem is harder. So so the student who did this work, the major part of this work, only used the variational method to solve the problem. It's also a common method used for solving problems with topic models. So for the evaluation, I think I want to just briefly mention that to finish the talk. So this is some result from MP3 review set from Amazon. This time we don't have aspect level ratings, but we try to see if we can discover interesting aspects. These are the aspects discovered from low rating reviews, and these are aspects discovered from high rating reviews. And you can see they did comment on different things. When they don't like the MP3 player, they complain about battery life, access rate, and service. But when they like it, they talk about some other aspects. This is quantitative evaluation of aspects, and we compare with the gold standard aspects in TripAdvisor, and we see if we discover similar aspects. But here, yeah, so I leave out the detail just in the interest of time. I'll send you the slides so that you can. Let me see. The main conclusion, so I want to just show this interesting result. Here it shows basically we compare the current model with two-stage models. There are naive two-stage models where the topics are discovered by LDA or some other simple method. But there are also a strong two-stage model where we use our predicted aspects to segment the sentences, to force sentences grouped into aspects. And then we run the older model. Now the difference is that in the new model, those assignments are soft, and they are not necessary by sentences. So one sentence actually, this is a good timing, so one sentence actually got split into multiple aspects, unlike a uniform red sentence, green sentence. So this is what's happened in the unified model. So it turns out that this is not very good, because the strong two-stage baseline is better than the unified model. That means it's important to respect the sentence boundaries when you segment the aspects. And a topic model like LDSI model doesn't achieve that goal. And because of back-of-words assumption. So this is just this just indicates that inferred weights also make sense, because when we group reviews based on the same weights, then their overall ratings have lower variance and lower standard deviation. It just means they are more coherent. They do share similar opinions. That's an indirect way to show that the inferred weights also make sense. The variance is lower than the variance of the whole group. So those people do share similar opinions. So to summarize this talk, I basically introduced a new problem called the Latent Aspect Rating Analysis, where we discover aspects, aspect ratings, aspect weights from review text that can enable a number of applications. We also developed two new generative models for doing this work. One is when users specify keywords. The other is when the users don't specify the keywords. So the model actually would have to discover the aspects as well as decomposing ratings. A byproduct is aspect-specific sentiment lexicon that can be used to predict the sentiment of other regular text, like a tweet or blog articles. And there are many interesting applications that I mentioned. So for the future work, I think there are a number of issues that are interesting to address to improve the model. So first, to create the back-of-words assumption and perhaps model the proximity or coherence of topic in the case of opinions. Another direction is to model the authors and incorporation of social networks. Yeah, that would be really interesting. A third issue is the trustworthiness of reviews. Can we use basically the support of reviews to model trustworthiness and then discount some review in that way? And finally, I think we might want to move to ordinal regression, which seems more natural to model these ratings than the linear regression that we commonly use. And there are many evaluation issues that we also already discussed and other additional applications. So yeah, I skip the acknowledgement. Thanks very much.